A growing population and a big appetite for resources are pushing the planet to the brink as humankind extracts scarce materials, pollutes the environment, and consumes vast amounts of energy. If we want to halt climate change, we will have to make the transition to renewable power and fuels work. This means adopting smart, economically feasible ways of storing regenerative energy and coupling energy sectors. We also need innovative processes for closed-loop material cycles that will enable us to use scarce resources in a more sustainable way. The ZSW is addressing both of these issues by conducting application-oriented research into power-to-X processes, that is, using electricity to produce renewable fuels. We are also investigating ways of recovering finite raw materials, such as phosphorus. An electricity-based hydrogen production facility went into operation in Grenzach-Wyhlen in southern Baden in 2019. Part of the Power-to-Gas Baden-Württemberg Lighthouse project, this 1 megawatt reference plant draws renewable electricity from the adjacent Energiedienst AG hydropower plant to produce up to 500 kilograms of hydrogen per day. The ZSW has an extensive live monitoring system to measure all process steps and track data. This advanced facility is equipped with a research electrolyzer developed by the ZSW. It serves to test improved electrolysis components in the power range up to 500 kilowatts under real-world conditions.
Our research facility gives us the opportunity to test and optimize innovative materials and components in a real environment.
For example, we are currently testing an advanced alkaline electrolysis technology under real-world conditions. Comprised of newly developed low-cost electrodes and fewer individual components, it is better suited for mass manufacturing. As part of a broad industrial dialogue, we are working with Baden-Württemberg-based companies to industrialize this new technology and want to help suppliers gear up for it. Slated for further expansion in the years ahead, this site is among the real-world laboratories designated to support the German Federal Ministry for Economic Affairs and Energy's exit from fossil and nuclear fuels. It will provide hydrogen and process waste heat to various users on site. In this project, ZSW is developing production-optimized electrolyzers and is testing them in a real-world environment. Electric and hydrogen vehicles are making transportation more climate-friendly, but aircraft and ships will run on hydrocarbon fuels for some time yet. This carbon can be captured directly from the air in the form of carbon dioxide. And that is a matter of global importance because the day is nearing when fuels will also be produced at remote locations that have excellent solar and wind conditions but lack sources of concentrated CO2. Our research focuses on developing and testing a CO2 extraction process that consumes far less electricity. We use the waste heat produced in related steps, such as electrolysis and synthesis, to reduce overall power consumption. This integrated process has already been implemented in an application-oriented demonstrator. The technology scales up well to higher output classes.
CO2 aus der Luft zu gewinnen ist dort sinnvoll, wo CO2 gebraucht wird.
Capturing CO2 from the air makes sense in places that need CO2 but lack concentrated sources of it. That is, locations for electricity-based production of renewable fuels with excellent solar and wind conditions, such as North Africa, Australia, and South America. Our research extends beyond Power-to-X. We are also exploring innovative processes for closed-loop material cycles, for example, to recycle plastic and phosphorus. Phosphorus is an elementary building block of all life, but access to naturally occurring deposits is limited. Up to 50% of Germany's demand could be recovered by recycling sewage sludge. Joining forces with partners in science and industry, the ZSW is developing a new method of incinerating sewage sludge in a fluidized bed, where a high-temperature cyclone separates ash rich in phosphorus from the flue gas stream. This plant is equipped with all the instrumentation needed for comprehensive mass balancing. Ash products and the bed material are characterized for particle size distribution, composition, and melting behavior. The ZSW also provides access to its proven lab infrastructure and methods as a service. We develop and test the building blocks of industrial technology for electricity-based production of hydrogen and synthetic fuels and put these components into practice on a technical scale. We research materials and methods for manufacturing electrolyzers that are suitable for mass production and scalable. We have our own electrolysis block technologies up to the megawatt scale. We characterize catalysts and functional materials with regard to kinetics, conversion and degradation. We advise our industrial clients on tasks ranging from basic engineering to commissioning and monitoring commercial plants. We have already constructed 3 power-to-gas plants with up to 1 megawatt capacity each. We contribute to our customers' success by providing a wide range of testing options in ZSW labs and in real-world environments. And we also support our customers' efforts to branch out into new lines of business. The ZSW can build upon 30 years of trusting collaboration with partners in industry, research and government. Our customers appreciate our knowledge of industrial processes, our flexible can-do service, and our holistic skill set. Get in touch. We are looking forward to talking to you. Visit us in Stuttgart-Vaihingen or at zsw-bw.de.